Next concept, summations of series using different integrals as the limit. The expression of the form limit n tends to infinity 1 by n sum of r equal to phi of x to psi of x r and f of r by n equal to integral a to b f of x dx. Where summation is replaced by integral sign. R by n is replaced by x. One by n is replaced by dx. To obtain a, limit n tends to phi of x by n and b equal to limits n tends to infinity psi of x by n. The value of limit n tends to infinity n factorial by n power n whole power 1 by n is equal to 1 by e option B e option C e squared option D 1 by e squared. Let a equal to limit n tends to infinity n factorial by n power n by 1 whole power 1 by n. Taking log on both sides, log a equal to limit n tends to infinity n factorial by n power n whole power 1 by n. Limit n tends to infinity 1 by n 1, 2, 3 up to n by n power n factorial. Equal to limit n tends to infinity 1 by n here log 1 by n log 1 by n 2 by n n power n can be split like this. So, log 1 by n using product rule, log 1 by n plus log 2 by n up to log n by n. You can write sum of log 1 to n 0 to r by n. Log a equal to integral log x dx. To find the in place of summation, you take integral sign. Log in place of this x in place of 1 by n dx. To find the limits, limit n tends to infinity, you take r by n. You take one limits n tends to infinity 1 by n, that is 0. You take n 1 0 to 1 log x dx. Log 1 0 minus 1 minus 0. So, log a equal to minus 1, which implies a equal to e power minus 1 equal to 1 by e. Option A is correct. Let p equal to limit x tends to 0 plus one plus tan square root x whole power 1 by 2x then log p is equal to one by 2 1 by 4 2 1. Log p equal to limit x tends to 0 plus log of 1 plus tan square root x whole power 1 by 2x. Secant squared root x. That is secant root x. This will be cancelled. So log p equal to limit x tends to 0 plus log secant root x by x. If you apply 0, here 0, secant 0 1, log 1 0, 0 by 0 form. For log x, if you differentiate log x 1 by x, that is 1 by secant root x. Further, if you differentiate secant root x into tan root x, for root x the answer is 1 by 2 root x. If you differentiate the denominator, answer will be 1. Log p equal to so this will be cancelled. Limit x tends to 0 plus tan root x by two root x. Differentiation of root x equal to 1 by 2 root x. 1 by 2 tan root x by root x. So 1 by 2 into 1, answer 1 by 2. Limit n tends to infinity, n plus 1, n plus 2 up to 3n whole divided by n per 2n whole per 1 by n. Is equal to nine by e squared three into log 3 minus 2 18 by e power 4 27 by e squared. Limit n tends to infinity n plus 1, n plus 2, etc. n plus 2n divided by n per 2n whole per 1 by n. Applying log on both sides, log a equal to limit n tends to infinity. If apply log, 1 by n will come from this place. Log of n plus 1 by n, n plus 2 by n, n plus 2n by n. So there are 2n terms, therefore n, that is n power 2n. log a equal to limit n tends to infinity 1 by n log n plus 1 by n log n plus 2 by n plus etc. log n plus 2n by n. Summation n plus r by n r equal to 1 to 2n equal to limit n tends to infinity 1 by n r equal to 1 to 2n log one plus n by n 1 r by n. Log a equal to limit n tends to infinity so this can be written as in place of Seidel sign log 1 plus x for in place of dx limit n tends to infinity r by n. If you take r equal to 1 limit n tends to infinity 1 by n equal to 0. So lower limit is 0. To find the upper limits limit n tends to infinity r by n. In place of r you have to substitute 2n. So limit n tends to infinity equal to 2. So 0 to 2 log 1 plus x dx. So put 1 plus x equal to t dx equal to dt x equal 0 implies t equal to 1 x equal 2 implies t equal to 3. Therefore log a equal to 1 to 3 log in place of 1 plus x you take t in place of dx you take dt. So in the log x dx equal to x log x minus x. So log a equal to applying upper limits 3 log 3 minus 3 minus applying lower limits 1 log 1 minus 1 3 log 3 minus 3 minus 0 plus 1 3 log 3 minus 2 equal to log 3 cubed minus 2 log 1 calculated as 2 log e to the base e log 27 minus logs of base e log 27 by e square to the base e. So log a equal to log to the base e 27 by e squared, which implies a equal to 27 by e squared. So option D is correct. Limit x tends to 0, 1 minus cos 2x into 3 plus cos x whole divided by x tan 4x. Is equal to minus 1 by 4 1 by 2 1 1 2. So multiplying numerator denominator by x. So x square tan 4x equal to limit x tends to 0 2 sin squared x by x squared so x by tan 4x. 2 into limit x tends to 0 sin squared x by x squared, limit x tends to 0 3 plus cos x by 1, limit x tends to 0 x by tan 4x. Equal 2 into limit x tends to 0 sin squared x by 4x squared sin squared x by x squared So if you apply the limit sin x by x equal to 1, therefore this takes the value 1 squared. Here 3 plus cos 0 equal to 1. Limits x tends 0 4x by tan 4x by 1 multiplying and dividing by 4. 2 into 4 into 1 into 1 by 4, that is 2. Option A is correct. The values of P and Q for which the function f of x equal to sin p plus 1x plus sin x whole divided by x if x is less than 0, q for x equal to 0, root of x plus x squared minus root x x power 3 by 2 for x greater than 0. This condition is for all x belongs to R. Or option A, P equal to 5/2, Q equal to half. Option B, P equal to 3/2, Q equal to half. Option C, P equal to 1/2, Q equal to 3/2. Option D, P equal to half and Q equal to minus 3/2. F of x equal to sin p plus n x plus sin x whole divided by x. X is less than 0. Q x equal to 0. Root x plus x squared minus root x by x power 3/2. X is greater than 0. First find left hand limits. X tends to 0 minus f of x, which is equal to limit h tends to 0. In place of 0, we have to apply, in place of x, we have to apply 0 minus h sin p plus 1, 0 minus h plus sin 0 minus h divided by 0 minus h. Equal to limit h 0 sin of minus theta minus sin theta minus sin p plus 1 h divided by minus h plus sin of minus h minus sin h divided by minus h. So LHL equal to limits has than 0. If we can eliminate this sin p plus 1 h divided by p plus 1 h into p plus 1, multiplying and dividing by p plus 1 plus limit h tends 0 sin h by h. So 1 into p plus 1 plus 1, which implies p plus 2. So LHL equal to p plus 2. Limit x tends to 0 plus f of x equal to limit h tends to 0 equal to limit x tends to 0 plus root of x plus x squared minus root x divided by x into root x. Limit x tends to 0 plus root x into 1 plus x minus 1 by x root x. This will be cancelled. Equal to limits x tends to 0 plus by x. So limits h tends to 0 1 plus 0 plus h minus 1 divided by 0 plus h. In place of x, you write 0 plus h. Limit h tends to 0 root of 1 plus h minus 1 by h. Root 1 plus h plus 1 by h into root 1 plus h plus 1. Here we are apply rationalization method, multiplying and dividing by root 1 plus h plus 1. Limit h tends to 0, a minus b into a plus b, a square minus b square, that is 1 plus h minus 1 divided by h into root 1 plus h plus 1. This will be cancelled. Limit h tends to 0, h by h into root 1 plus h plus 1. This will be cancelled. That is 1 by 2. So RHL is also equal to 1 by 2. So limit since f of x is conditional at equal to 0, limit x tends to 0 minus f of x equal to limit x tends to 0 plus f of x equal to f of 0. So left hand limits p plus 2 equal to right hand limit 1 by 2 equal to q. So p equal to 1 by 2, p plus 2 equal to q. Q equal to 1 by 2. So P equal to 1 by 2 minus 2. P equal to minus 3 by 2. P equal to minus 3 by 2, Q equal to 1 by 2. So option B is correct. Limit y tends to 0, root of 1 plus y by y power 4 minus root 2 divided by y power 4 exists and equals one by 2 root 2 into root 2 plus 1. exists and equals one by 2 root 2. Does not exist. Exists and equals one by 4 root 2. Limit y tends to 0, 1 plus y power 4 minus root 2 divided by y power 4 into root of 1 plus y power 4 plus root 2 divided by root of 1 plus y 4 plus root 2. We have to rationalize. So multiplying and dividing by this term. So consider numerator. This is a minus b here, a plus b. A square minus b squared. Limit y tends to 0. That is a squared minus b squared divided by y power 4 into 1 plus root 1 plus y power 4 plus root 2. Limit y tends to 0, root of y plus y 4 minus 1 divided by y power 4 into 1 plus root of 1 plus y power 4 root of 1 plus y power 4 plus root 2 into root of 1 plus y 4 plus 1 divided by root of 1 plus 4 plus 1. A minus b into a plus b, a square minus b squared. 1 plus y power 4 minus 1 divided by y power 4 into whole of plus root 2 into 1 by plus 1. This will be cancelled. So 1 by here 1 plus root 1 plus root 2 into root 1 plus 1. So option D is correct. So go through all concepts, continuity, differentiability and limits. Thank you.